Hello everyone, this is tgKang's math time again. Okay, today's question is 2018 November November time zone 0 HL paper, and then paper 1, question number 3. Yeah, this is about the trigonometric function. Okay, the question is, consider the function gx goes to be 4 cosine x plus 1, and then there is a domain of x. Okay, for a goes to be negative half, sketch the graph of y goes to be fx, indicate clearly the maximum and minimum values of the function. Okay, you have the tip for this one is we have, okay, y goes to be cosine x graph, which is, we start from the here 1, and then the period is 2 pi. We divide by this into the 4 regions like this, and then we can draw the box like this. The cosine graph is starting from 1, right, and then it goes down and then goes up, so that the graph goes to be something like this. Okay, here we have pi over 2. And then if we extend this up to the negative pi over 2, then it goes down like this, something like that, right? And then if we change this into the y goes to be a cosine b x minus c plus d, and then I will draw this with only the positive a case. And then first, okay, how we say that the c and d, those two values are related to the translation, and then b is about the period. Okay, period goes to be 2 pi over b, right? A is so-called the amplitude. If a is negative, then I can say flip the graph. So whenever I say I'm saying that, okay, this box, you just consider this box and then stretch this box in this way, or stretch this box in this way, and then you can translate this box to somewhere, right? So that whenever you draw the graph, first you draw c and d first, so that this point is c and d, which means this point moves to this c and d point. From here, you draw, this is the left bound of this, the red color box, right? Left bound. And then the top side, then you can draw the bottom side, the boundary, so that this amount is actually your amplitude. This is so-called the absolute value of a, right? So that this side is y goes to be c plus absolute value of a. This side is y goes to be c minus absolute value of a. And then the a is midline. And then this is your right bound. This length is your actually period, which is actually 2 pi over b, right? And then you just divide those things by 4 regions. Then after that, you just draw the cosine graph from here, then it goes down, goes up. If your a is negative, you draw like this. In this case, C. This is the tip for the first question. Okay, you go back and draw. A is minus half pi, which means the domain here is negative half pi to pi over 2, and then there is no the horizontal translation, right? Only we have the vertical translation, which means here we have y equals to 1, and then from the top, for the top side, we have adding 4, so that we have 5. The bottom, to the bottom, we have subtract by 4, so that there is y goes to be negative 3. And then at the center we have y-axis here, and then we need to have x-axis. There is somewhere here, because y is 1 here and the y is minus 3 here, right? After that, the domain is from pi over 2, and then another one is negative pi over 2. In this case, the period is 2 pi actually, so that within 0 and pi over 2, we have 1/4 drawing of the cosine graph, which is this shape, right? So that, yeah, we draw from here, and then, yeah, draw up to there, and then we just lift like this into this side. Yeah, this is y goes to be 4 cosine x plus 1, right? Then, okay, what is the indicate clearly the maximum and minimum values of the function. Yeah, this is the maximum. Here we have max, and then here we have minimum. We have two identical minimums, so that maximum value only, right? Maximum y goes to be 5 at actually x is 0. Minimum y goes to be 1 at x is pi over 2 or negative pi over 2. Yeah, up to here is number 1. Number A. Number B, write down the least value of A such that G has inverse. Okay, I'll give you the second tip about inverse function. What you need to remember about the inverse function is only 3 things. The first one, inverse function. Yeah, how to calculate, you use interchange x and y each other, and then you rearrange with y, that is your the inverse function itself, right? But here what I want to say is, after that you need to reset the domain, which means the domain of f goes to be range of f inverse, and then range of f goes to be your domain of f inverse. So whenever the question is asking about the f inverses domain or range, yeah, you need to go back to the original function to find the domain and range. Yeah, after that, from there you can find the answer for that, right? The second thing, when the inverse function is existence, when the inverse function is existing, yeah, that is one-to-one function. If your original function is only the one-to-one, then there is inverse function you can find. And then the third one, graphically, graphically, okay, the original function, and then your inverse function is y goes to be x symmetry. Okay, those 3 factors you must know, and then there are no more than this about the inverse function question. So that, then what is this question? Okay, this question is about what is the least value of a such that G has an inverse function is existing. Yeah, it must start from here, and then up to there, that is only the one-to-one function, right? If the inverse domain is, yeah, starting from less than 0 here, yeah, if it reaches to here, then, yeah, one-to-one is broken already, right? So that, and then the question is starting from the right down. It says that you don't need to calculate, you don't need to show any your working process here, just write down the answer. Why? Your mark is only 1, right? So what is the answer? Okay, the least value of a is 0. Number C. For the value of a found in part B, yeah, for the value of a 0, write down, okay, y gx was 4 cosine x plus 1, which means I rewrite this, okay, y goes to be 4 cosine x plus 1, and then I switch x and y, means that x goes to be 4 cosine y plus 1, x minus 1 goes to be 4 cosine y, so that y goes to be cosine inverse x minus 1 over 4. So that you can say that G inverse x is cosine inverse x minus 1 over 4. That is the form of G inverse. Write down the domain of G inverse. Find an expression for G inverse. And this is the answer for number 2. Answer for number 1. What is the domain of G inverse? domain of G inverse is same with range of G, which is range of Z is from here to there, right? So they 1 to 5. That's why how we can write here the answer x is from 1 to 5. So this question was about the trigonometric functions graph. Yeah, especially this is about the cosine x. The first, okay, how to draw the cosine x graph, and then the second one, okay, what is the inverse, when the inverse exists, or those things. Yeah, and then here, yeah, 1 to 1, the inverse exists, and then the domain of inverse is coming from the range of the original function. That's everything about this number 3 question. Okay, again, yeah, have a good math day today.